Welcome to a new episode and video on my Arduino MegaADK, right here, connected to breadboard with electronics and connected to fischertechnik mechatronics, as well as a changed standard with a flashlight which replaces the lens lamp that I used to use. Quick catch up. The lens lamp was supposed to signal the phototransistor from fischertechnik and then through this voltage divider give input to the board. However, it turned out that the lamp merely glared instead of really a bright light like this. So that was decided to replace it. Next is the question, alright, so this doesn't make a dent. Well, the analog input gives a nice value, although not changing very much. When this light is on, the digital version, the digital signal from the voltage divider doesn't change to 0, not even with this lamp. So the question was, okay, what if I take the signal directly from the transistor and feed it to a new input? That worked. So the voltage divider can actually go, but I had to use well, let's say an improvised wire. So first thing is that I am going to change that, replace that improvised wire, which is in 13, I believe. Let me check. Yes, 13. And I have this very long wire. Why a very long wire? Well, the point is that I either should have cut a brand new wire or use this one and have a nice length. So this saves a lot of problems. Although now another wire goes out. Which is fixed now. So that is alright. And that is one thing. Then I tried to get the motor working through this transistor circuit. And although it works, considering the burning of this LED, the motor doesn't. With a distorted signal that's visible on the oscilloscope, the motor runs. Although it should run from here, from between the diode and the transistor, or transistor and diode actually in correct direction, it doesn't work then. My motors in other projects do run in the normal way. So why this isn't working, I don't know. It's a small motor, but so be it for now. Then what I want to test is right here now. So a probe on the resistor and a probe on another one, because why is this not working correctly? Well, it usually is. So let me flash the LED. And this goes wrong. Very wrong. This has to give a very short flash and that's it. Last time it did nicely, but why does it keep burning? And even worse, now I look at the oscilloscope, there is something that is very strange. So let's go to the screencast that I can show you what is very strange happening. So I am talking about this circuit, mind the mouse pointer, this circuit, and as I told you, this LED, very small, should only give a flash. I press the button, and after that this capacitor, electrolytic capacitor, because it has a plus and a minus, should discharge when pressing the button, and then it is a rather small quick discharge, so this LED should only give a very short bright spark and then be like this again. And guess what happens? Now I'll also watch now also watch the oscilloscope. This does not make sense. Why is this happening? These signals should not be... Oh wait. Right now the probes are there, so this should be happening, but why does it respond to the motors as well? No, this should not happen, because of course the probes are responding to this, but they should be like this for a mere second and be away. But this looks more like pulses modulation, so this doesn't make any sense. If this would be burning, this would be a constant line. So this is pulse modulation over an LED. Okay, that's just reasoning. Where does it get its power from? And I have to get some wires out of my way. This works too confusing. And this is the old mechanism for the lamp. So it doesn't make any sense anymore. Make sure that nothing is being touched by anything else. What happens now? Alright, that may be it. I will have to let it charge and then see whatever happens. Okay, one more thing. Okay, this is interesting. So it looked like that this resistor was touching the yellow wire. Not a problem in itself, but why is the LED doing nothing spontaneously? Very big question. Some wires were intertwined, or how do you call that? Touching each other. Let's check the real configuration. Being here, so talking about which one, I have only, oh no, I have two buttons, three buttons actually. So I have one button here but that's not the one. Then I have one here, also not the one. And then I have here one here, which is indeed with the capacitor. So in schematics it all looks nice, but I have an elevated yellow LED, which is somewhere. Which is not this one. It gets its feed from 3. So this means that where is 3? Oh, here. So this one is the elevated one. Elevated yellow, which is also in the code. Elevated yellow one. Yeah. So what does the serial monitor do? Also with respect to this, pressing the button. Oh, now it's strange because it doesn't do a thing anymore. And last time, when I even pressed the button very shortly, there was a flash. So I'm not quite sure what has happened now. Where should it get it? That's what you get when you do something you don't intend to do. You get mixed up like now. Signal is from 2. And this is input. So this probe is after the switch. And so is this probe actually. This is input 2. A5 then, yes, correct. So I should be measuring A5 as well. Or printing A5, which is actually better, but I'm not doing that, I think. Am I printing A5? Nope. Not printing A5. Yeah, I am. Right here. A5 is 194 right now. Which is weird, because I'm not even touching it. What is it doing now? Pin A5. Pressing the button. 199. Releasing the button. 186. Pressing the button. 177. Does it make sense? Okay, I am removing because this probe, this one is connected to ground. So I should actually be connecting it to, mind the wires, not to ruin anything. I should be connecting this right here to the feed of the capacitor. Oh, this is interesting. So yellow is now the feed of the capacitor. Blue is the signal after the switch, before the LED. So what causes the LED to burn or not? Riddles. Alright, some more thoughts on this problem. When I look at the schematics, port 2, resistor 5. Well, a resistor brings down the voltage, but it's not that much. It's a very low resistance. But then it powers the capacitor. However, looking at the code, it is very clear that the output, which is from analog out pin 2, has only 64 out of a possible 2 to the power 7 is 256, or maybe less. So it's not that much. Considering the length of this, and then yes, I do mean this line. So 64 is the small one upper, and then this is what remains, and that is 0. So how to deal with this? It gets power, but not much. Then looking again here, what does it do? Because it has had now some time to charge, and then I'm talking about capacitor. By the way, this is not a lamp, this is just a shiny surface. Okay, let me press the button. Yeah, alright. So if I then change 64 into 128, it should have some, let's say, half of the period. Sounds about right. So the full bandwidth is 256. Is that true? That remains to be seen, because it's very low now. Okay, but 128 in binary, 2 to the power 6, I think. To the power 7 is 520, or I get mixed up a bit. Let me find out quickly. Calculating. 2 to the power 3 should be 8. Yes. 2 to the power 6, 64. 2 to the power 7 then is 128, which makes 2 to the power 8 is 256. But that's a problem, because now it's completely blank. So let me go back to 2 to the power 7, 128. And this brings a question, because why can't I have apparently a full period? Let me try another value. 256 can't apparently, so let me change it to 250. See, 250, alright. But what does it have as an effect on discharging? Well, this is again the effect that it should have. Just a little flash and then it's blank again. So to be honest, I don't get it. And in the meantime, something weird as well with the motor, which is this signal. Now it's running, and you can see it is running right now. So there's something weird going on. Anyway, and now it stops again. No signal right here, and then the signal comes back. Why? Pressing the button and short flash. Okay, I'm changing the value back to 282. Let's say 200. Alright, 200. What does the LED do? Burning. It doesn't flash anymore. Okay, back to 250. What does the LED do? A short flash. At least very strange. But then again, am I looking at the correct thing? Let me diminish the light so I can see the LED better. Now it gives a short, just a very short flash. Or is it? Okay, less light even. Oh, look at that. That is different than I thought. Now you can't see, now you can. This is off, and still the LED. So it does give a bright flash, and then it keeps on burning, but very low. So that is called something like misconception. Something is happening, but you don't see it happen. So once again, the oscilloscope doesn't lie. You don't see it, but it's there. So this LED keeps burning because there is a continuing discharge as long as I keep it pressed, the button that is, but the big discharge is gone. Very different idea. What next? Alright, a very short different topic, which is this LED. It seems not to do anything. Is it connected? That is the big LED, big yellow one. Which is which? It is coming from pin 3. I have been looking in that earlier. That is this one. So this. Is it programmed anyway? analog out pin 3. Oh, to motor and propeller, right. So what is the value of it? Pin 3 is 3. Oh, that's not doing much, obviously. So I have to look here. Oh, but it is 512. Aha, wait a second. 512. But if I look, no, not here. If I look here, this is about the maximum I can give the output. So if I change this to 250, what does it do? Does it do anything anyway? And that is to say, is it connected? Right now I have to say it doesn't look like it is connected anyway. This wire is not feeding. Oh, it is. It actually is connected, but not in a nice way. It is connected through this mess of wires, and I have to be very careful not to touch anything else. So this wire, this green wire, is connected to this wire which has left this configuration. So basic, no, which is connected to this wire, which is connected here. Is connected here, is connected to this one, and to the LED. So the LED should do something. Question is, does it? Okay. Release the probe here and connect it, let's say, here for now. And I can't say it's a good value. Now it is. Does it burn? Hardly. Okay, so that's the next thing. But time's up. So I have to look into this. And that's it for this episode. So short recap: testing RC circuit with a result that I could have expected but didn't, and then rewiring here, and some checkout needed here to come. Thanks for watching. If you like this episode, if you like this video, please subscribe to my channel, give it a thumbs up, leave a comment or suggestion. You can also follow me on Twitter. Please retweet, like and leave a comment. You can also follow me on Instagram. Please like and leave a comment. They're all all listed in the description box under this video. Please support my blog by making a small donation. You can also decide to become a patron and have your name mentioned as a supporter. More information under this video once again, and on my website, which is also listed under this video. This is of course going to be continued. So thanks for watching, and bye bye.